All right. Hello, everyone. Thank you for joining us. Mike, I'm one of the co-founders and I'm the CEO at Tecton. We have a really cool presentation that we wanted to share today. It's from a really interesting company. At Tecton, we get the opportunity to see a lot of different applications of AI, machine learning across a lot of different types of companies, and this one is one of the most unique and one of my favorites. Flo is all about revolutionizing women's health, and they've got a ton of really cool applications of AI that they're working on, both in predictive ML and a lot of new generative stuff. And so I want to welcome Demetris and Andrei here to tell us a little bit about that and their experiences in scaling the ML infrastructure at Flo. So I'll let you guys take it away. Welcome.
Thanks, Mike. Thank you. Hello, everyone. My name is Andrei. I'm head of data science, and I have also Demetris with me.
Hello, everyone. I'm Demetris, and I'm a data science lead at Flo. I'll share our presentation, and we can start getting the ball rolling. Here we go. Perfect. Hope that this works and that everyone can see this.
Yes, so basically, as Mike mentioned, we wanted to share our story about scaling machine learning engineering and Flo, and some, key lessons, key challenges, key decisions that we had to make, and at the end of the day, the key lessons, which we also hope will be useful for the broader community. So just a little bit about what is Flo. We think about Flo as an essential health partner, and we focus on the female health issues. Basically, I think we are one of the players in the field, which these days people tend to call femtech. Basically stands for, female health technology. So that's kind of our focus, and Flo is actually a mobile app. So we deliver the value to our user and the whole user experience through mobile app available both in iOS on Android. Just some key numbers. Basically, we are number one by installs. I think we have 55, and it's already probably more millions MAU. More than 140 millions of revenue, and basically some other stats that you can see. So our goal is also to become like a medically, or to be actually medically sound service. That means that we have also our own internal medical team, which is involved in basically like creation and verification, different sorts of content and insights and things that we have in the app, and we work also with the broader community of medical experts, and we have our medical board. So basically, I think that's one of our key business principles, is that we want to stay medically accurate and provide the accurate and reliable insights and information for our users. So a little bit about the experience, like what the users can actually do with the Flo. And so I hope it also gives you some sense of, actually, I say it's a mobile app, but there is underneath that is quite sophisticated, infrastructure, and also including data infrastructure, machine learning infrastructure. We create our own content, we create videos, text content, images. So the core experience, Flo has started as a period tracker. So I'm going to go a little bit from left to right. And it started as a period tracker, and basically the users can log periods and symptoms, and then we sort of recommend the relevant educational content based on certain parameters and so the data that they entered. Then the users can also interact with chatbots. So we have a number of like checkup scenarios. Basically, if we see that something it doesn't look right in the data or like in the profile of the user, then we can suggest to do a checkup in the form of a chatbot, and so the users can basically either get more confidence that perhaps they should visit a doctor, or kind of our chatbot will say, well, like we do not see any issue at the end of the day. So chatbot, we also have a community, which we actually also is quite an interesting concept. It's a anonymized community, so basically means that the people do not share their identity and the real names, nothing. So that concept kind of allows our users to discuss very sensitive topics that would not be able to discuss elsewhere, like in the public social networks. And so that basically keeping them totally private, it helps people to like open up. So at the end of the day, you can see that we offer quite a lot of different kind of services inside the app. They are all connected in some way, right? So they're all driven by the data that people enter. We also have like a number of predictions. So our key algorithm is cycle prediction, which we've been working already for several years now, and some number other types of machine learning application, right? You can sense, like recommending content, chatbot, community auto moderation, like many other things. So basically, for us, like at some point, it became evident that we have to invest into machine learning, like strategically, right? And that was around, I think, 3 years ago or so, where the decision was made. And actually, this is where I joined Flo back then. I joined from Microsoft, and then Demetris joined slightly after to lead one of our team. Actually, was at the end focusing on building the platform, and that's kind of the story that we want to talk you today. So like when I joined, as I said, there was already production machine learning at Flo, but it was I wouldn't say it like ad hoc, but it was basically done. There was no standardized approach, standardized technology. Things were done like for different use cases. There've been different workflows. All of these fun things like copying model artifacts somewhere on S3 bucket, and then like reading them on production when serving user requests, so non-standardized serving structure, all of that kind of things. And like before we really started focusing on the actual like machine learning, I started thinking about kind of our key principles that our team should like agree on, and that should also give you a little bit of sense how we are organized, or how we kind of envisioned ourselves to be organized. And so like 3 key principles, and number 1 is the most important, is that we consider that Flow machine learning engineering is an engineering discipline. So that means that we basically think about machine learning, use cases or machine learning projects as an engineering project with all typical engineering attributes associated to it, right? So we do not see it as just pure, kind of statistical exercise, works on my machine kind of exercise. It's really, we build from like day one stuff that supposed to run on production, and that's what kind of the software engineers often do, right? So we also automate things. We kind of really care about cycle time at Flo. So meaning we try to sort of think how we deliver a smallest increment possible, right? So, and that smallest increment should be able to be delivered to production. You know, kind of CI/CD automation. So all of those kind of things, we said, okay, this is how our product engineering works, and we will also inherit all of those principles and processes, including the Scrum process that we use across the organization. So the second principle, well, basically, it's, as I said, stuff that we build is the same team that runs and operates it. So this is very important. It is again consistent with our whole engineering organization. So the engineers who build features, they are also responsible for basically make sure that those features are running, or if in case of incident, then we have an incident management process that allows us to organize to reduce time to fix. And the same thing should have happened in machine learning use cases as well. So it was the second principle. The third principle, I think this is more how we are organized as a business, as organization. So what for us is the ultimate metric is the impact. We talk about impact quite a lot in business. And so like as machine learning, well, not surprisingly, it's a kind of, expensive expertise. It's a very, rare expertise. Time to hire is well, can be quite significant. So we have very limited resources, and with very limited resources, obviously our challenge is to focus on the business impact, kind of figuring out which use cases, which scenarios bring our value to our users and value to our business at the end of the day. And we are very much focused on the results rather than on the activities, because kind of that doesn't make many people excited with Flo if you just say, someone spent 3 months of like doing something cool, and then the next question will come like, okay, what's the business impact? And if it's not measurable, not justifiable, then kind of all of those cool activities almost do not make sense. And so the challenge that comes with that is, well, how do you ensure that you are doing the right thing, right? So how do you ensure that you're focusing on the right use case, and how you ensure that you're doing it right? So basically you deliver things the way that it has to be. And so this has come the need for basically a scalable, repeatable process that would allow us to experiment faster, right, in our machine learning projects. And so following from this principle, we started thinking, okay, well, we need the repeatable, scalable process that allows us to sort of satisfy those principles and be able to experiment faster. So, and what we then realized is there is this quite, I think, known paper from Google, which is called ML Test Score. And what that basically does is it provides quite a pragmatic method to assess the maturity of the machine learning projects. So it is it's not academic. It's written by the people who analyzed, I think, dozens of projects within Google at the time, and it has like very pragmatic, actionable, basically tests. They call it tests. It's like basically questions that you have to ask, and based on the answer, you can assess the maturity of your process and your infrastructure and your technology. And it basically has these 4 dimensions. I'm not going to go into details, but I encourage everyone, in case you have not read that, it's actually, I think, quite inspirational. It was quite inspirational for us and pretty useful. And then basically at the end of the day, you can sort of, it gives you this maturity level score. So you can have like a basically quantitative measure of how mature you are. And so our goal was, we did an assessment back then at the beginning, so we got some score, and then we wanted to say our like aspiration is to become exceptional. So exceptional is the highest level in this framework. It basically where you get like more than 5 points, so more or less all of the dimensions of your projects, kind of on a pretty high level. And that is how we set up, let's say, our goal is to move along this maturity, right, from where we were. And basically the rest of the presentation, we will talk about like, what did we do, how did we think about this challenge, and also how did we partner with Tecton on this journey, and what is the role of Tecton, because it was and still is quite significant. And I pass the microphone to Demetris.
Thank you, Andrei. I'll start taking everyone through the journey we had, as Andrei said. And, I think that sometimes the best ways to showcase why something is relevant and why something is needed is to provide a counterexample, an example of a project that would have taken place if the platform as we have it today wasn't there. And we have this example scenario here with a recommender system. Let's imagine we're back at the time that the ML platform was only a dream. We had none of the infrastructure that we have today. We were back at the time that, as Andrei said, we had some productionized stuff, but they were not as robust, and the infrastructure was not yet at the levels that it's today. And let's examine how such a scenario would have played out. So in this scenario, with the recommender system, let's say that the product manager comes and says, okay, we've decided that we really need this new machine learning model that would power our recommendations for the library. Andrei has shown in an earlier slide that we do have a library, a carousel of different suggestions that the customers could scroll through and choose. And, it's a very classic ML problem to choose the most relevant content to present to the customer. So let's say that a data scientist disconnected from the engineering organization. Remember, Andrei earlier said those principles about how we believe that machine learning should be an engineering discipline, but this is the dystopic past, so things are still disconnected, and this data scientist is assigned to run this project. They go through the process. It's a rigorous process. They're not bad at what they do at all. They collect all the data. They train a model. It's a good model, and they do evaluate it. And it seems that everything is great. We have a model, and it's ready to be productionized. Things so far look good. But that's when trouble starts. That's when it's productionization where we will begin to face hardships. And what kind of hardships are we referring to if you don't have the right infrastructure, if you don't have the right platform? So, every machine learning model needs features to run on, and some of them are easier to get to than others, right? It depends on the type of feature. So in our example, we were saying, okay, we'll have the recommender system. Maybe it fits on the age of the customer, maybe the country they come from, to provide more relevant suggestions. And such kind of information, such kind of features are very, very easy to get. If we want to run online inference, we will get them from OLTP storage. And to just make it even more clear to people who are watching, what do we mean by online inference? We mean actual streaming. So the model is live, the app is being used, and it's all real time. So the person would open the home page and we want instantly to get the best possible inference and the best possible suggestions for them. And when it comes to offline training, which is at the time that the data scientist was just training the model, it was very easy to get the value from an analytical table. Now, we've got some features which are more difficult to get. So let's go through symptom history, for example. In such cases, things get a bit trickier. Why? Because you don't, you're not only going to retrieve a single value there, you want to perform some operations, such as aggregation. So you want to go through a history of symptoms or a window of symptoms and process all of them and sort of compute the final feature that would go into the model. And for the data scientist to do it manually at the time of training, let's say it was fairly easy. But when you want to productionize something like that, it gets trickier. And it could cause latency spikes in occasions where you've got a really high number of symptoms, for example. And latency is very important in any kind of app. You want the customer to have an immediate interaction, a seamless interaction. And where things get even more painful is anything that requires freshness. And what do we mean by freshness? We mean, I'll give you a really good example, which is straight from actually our app. So as you know that Flo, as Andrei explained, helps women track their period, track their cycle. So the moment a customer enters and logs the previous cycle, that very moment, the app needs to process that data, factor them in, and give out a new prediction. You don't want the app to only make a prediction based on past data. You want it to factor in every new information, even if you have just inputted it. And this is the same with the library here. If a customer mentions something only right then, or if there was some activity that is relevant to the content that needs to be shown, usually those are the best features as well. That are the most meaningful features. So you want this freshness, and if you want this freshness, this is really, really hard to get. You will need to get a combination of batch jobs and streaming jobs that will fill data in online storage, and you don't only need to do it for right now, but also for historical data. So let's say that we would try to build this and map this and look how it could have looked like. And remember, no infrastructure is in place, so all of this needs to be handled from start to end. And I don't think that you need to be technically savvy here to understand why this is a complex pipeline and why this is kind of painful to not only build, but to actually maintain once it goes live. And it is the Flow engineer that was asked to do this. He was not happy, not in the very least. It took him a long time to get where he needed to get. And after it was done, but the data scientist decided to go to another company, and things started looking grim, because even though it was a success that it was actually productionized, things weren't really looking that good in the end. Because what do you end up with when you go through such a process? You have a complex pipeline, which is shown very hard to support. There's the problem of inconsistencies between online and offline features. So the features that you actually serve and those that you're storing. And there's never that's never the end of the story in any kind of company, in any kind of ML project. There's always iterations. You always want to move forward. You always want to make improvements, right? So it's quite in our case, the product manager would come and say, okay, we have some new features. The model could be better. We need to refine these for this audience or that for that audience. there's always a need to make progress. And you can't really make progress if you have something which is so hard to maintain. If there are all these inconsistencies, and you have your new data scientists coming in, they cannot decipher what the old one was doing. They have to rewrite everything, and it's all a big mess. So then you come to sort of understand and realize that we would be looking for some solution, some tool that could give us the same pipeline for training and inference, so that the transition from one stage to the other would be seamless. Something which would allow for built-in materialization for the online store, a point-in-time correct join for dataset collection. What does that mean in terms of point-in-time correct join? I'll give a very simple example. Imagine that you have people and customers, and you have their age, which is like the simplest feature. And let's say that a customer joined, they were 17 years old, they were underage, and that probably plays a significant factor in some model, right? In terms of what result and what prediction will be made. Then we move forward a year later, they become 18, 19, let's say. If you are going to collect data to retrain the model, it's very important to have an easy way for your snapshot of data to be correct for the time that you're training the data. So if the activity you want to process was when the time was that the customer was 17, you want to have this correct equivalence and to train apples with apples and oranges with oranges. Then the other part is the easy feature share, right? So it's not just about having those features for just one model and just one use case and just being able to maintain that. No, it goes way beyond that. It goes to the fact that you will never have a single machine learning model in the company. You'll probably have an ML department because you want to ramp up your ML use cases and help in multiple domains. So it's important to be able to share what you're doing with other projects, and whatever work is being done, whatever efforts you're putting into productionizing something, building something, if there's an easy way to share some steps with the next project, which might be using some of the same features. So imagine like age being, again, a very intuitively easy example, which probably plays a role in a multitude of different models. You want to be able for every different model to access it, and you want to be able to share it. So what kind of platform, what kind of tool could give us all of that? It's hard to guess, but given that we are in a Tekton webinar, it's the first choice here on the menu. Databricks also offers feature store. HubSpot, Feast is a known feature store, but in the end, what we really wanted to go with is a feature store, and for Flo, Tekton has been Flo's choice. A feature store or feature platform is a more correct way to call it. So, how did that? How was it plugged in our ML platform, and how do things look like now? As you can see, Tekton, even though it's not in the center of the picture, it's the one item, it's the one box that is connected with everything else. It's in the bottom right, and it's connected to our environment where we will develop the models, where the data scientists and the machine learning engineers will be able to run their notebooks on Databricks, use MLflow to immediately containerize the models and serve them in production. Everything there is seamless. The transition is seamless, and exactly because everything goes through Tekton, once you have the model in production, you are guaranteeing that you have this consistency between the features that you were using during training and the features that you're serving in production when you go live. And you can see that for in terms of our data storage, you can combine stream jobs and batch jobs, and everything becomes much easier because all of those things that looked so complicated earlier, now for the data scientist, it's really much easier and more intuitive to get. They only get them from a single source. And we're moving forward to the present, and now we have the ML platform in place. We have managed to ramp up our capability significantly. And one of the actual models that we were working with as a data science team was the lifetime value model. That is, for every customer that joins, that installs the application, the business demands to know how valuable could that customer be, right? What kind of money should we expect to get from them? And this model already existed. As Andrei mentioned, we already had productionized machine learning even before the ML platform, but and there were problems. We had discrepancies between training and inference. Now with Tekton, we are serving features for both, and there's perfect synchronization there. Before, in order to just get the training data set, we had 20 different SQL scripts that needed to be run. There were data leaks. Now the dataset building is very streamlined. It's just a single API call. We guarantee guaranteed point-in-time correctness because of Tekton's out-of-the-box capabilities, which makes our engineers and our scientists' life much easier. We had no infrastructure to test the model. We had in shadow mode, there were no canary releases. Now with the ML Hub being a very important part of the platform, we have this easy separation between deployment modes. We have monitoring, and it's monitoring not just for not just the health check, whether the model is running and whether it's giving results, but also we have statistical feature monitoring to check whether there's drift. Then the feature pipeline required restart every month. We had drops in prediction with the feature aggregator being moved to Databricks and the results ingested into Tekton. That problem was solved too. Before, again, we had the case in which on some occasions, the data scientists would train the models on their local machines. It was slow, it was insecure. Now we have a collaborative notebook environment on Databricks. Everything is so much scalable, more scalable and secure and reproducible and easy to access and share between the different colleagues which work on them. Before we had model artifacts stored in Git. Now we've got ML Flow, allowing us to do experiment tracking and containerize everything. And as I already alluded to, in the past, the stakeholders were the first to identify any problems with the models. Nowadays, because of the statistical feature monitoring that we have in place, using Evidently AI as well, we have what we need to be the ones to understand when something goes wrong and when the model is drifting, when some feature is drifting, and so forth. You might ask, well, was everything so smooth? And because we are sort of giving you a perfect picture here. And the answer, though, is not. Not everything is perfect. It never can be perfect. Reality is always a bit more complicated. But still, that doesn't take away from the overall value of this project. So there was a very strong positive impact on everything, but there were some complications. For example, back when we started working with Tekton, even though it was the most advanced feature store at the time based on the comparison, a very thorough comparison we had made, we still had some problems joining streams on some different keys that and making some feature calculations on the feature platform side. And in order to solve that, we had to use an intermediate Databricks streaming job to calculate the feature and then serve it directly to Tecton. So we had to do our workarounds, which isn't perfect, but and it was just one obstacle in that case that we managed to overcome and still reap the benefits out of Tecton as a platform in general. The other part was that our use case, as I've explained earlier, you want this seamless and immediate communication with the customer, and you require sub-second inference latency. So when you when the model is called to run and delivers the result, you want this to be instantly served to the customer. And initially, we were not able to get where we wanted, but after close collaboration, we got there in the end. And Tecton has been a great partner in helping us achieve success in our use cases. Because I've been we talked about the dream, and it was Andrei's dream when he initially started paving the way towards this direction with the A strategy for Flo. We can talk a bit about the reality, how this dream became a reality, and how it keeps sort of evolving, and what's the current situation today in Flo. So currently, we have multiple models hosted in our platform, from things like the LTV models that I've just mentioned. So the first use case was the PLTV model, the predictive lifetime value model for the iOS funnel. But we have now models there for Android and the web funnel as well. We've trained churn models. We've managed to move the medical use cases as well, the cycles prediction, mode switch predictions, which predicts which customers are most likely to switch to pregnancy, and help them understand that there's a route to that as well, and a different version of the app that would allow them to tackle that part as well. Temperature model, which allows enhanced cycles prediction based on measurements of body temperature. And we have some models which are in progress, right? So the next best action model is another big dream of the company in general, to be able to optimize the interactions we have with customers and find the next best action and the next best offer for them based using ML and their behavior, and a lot more to come. But at this point, I want to give the microphone back to Andrei and talk about lessons.
Yes, thanks a lot. Just to conclude with a few lessons, I think the key, let's say, reflections looking back was, so number one is actually, this platformization strategy really worked for us as a strategy. As I said, we, like, these days, we almost don't talk about classic ML infrastructure. So when we start talking about ML infrastructure is in the LLM Gen AI space, which is like the new era, probably will be the topic for 2024. But like I think there's interesting dynamics where basically more mature you become, you consider basically machine learning is just a feature, just an application, like the same as the other features that we built, and we moved away from basically being somewhat special, fancy, or something that we do not know. It kind of runs from training to deployment to production operation to monitoring. And I think this is a good, some kind of proxy metric, if you do not speak anymore, in your kind of daily grooming sessions or in your backlog about the infrastructure, then it's probably a good, you're moving kind of in the right direction. And certainly, platform helped us, right? Another one, and I think there are some also remarks in the comments. Not everything like kind of works as one could expect at the beginning, because mainly I think for us it was extremely difficult to foresee like features and capabilities that we would need for our feature engineering, because we have some quite complex features, like really using, complex types or quite sophisticated kind of operation on streams, for example, right? So I give this example, joining two streams which have like different primary keys. So basically like um, some technical scenarios which you sort of realize only when you start building, like no matter how good you kind of think about them, um, when we start building, then we start figuring, well, you know what, that type of stream joins was not supported. And so we kind of got, yeah, at some point stuck, or we had to find some kind of like workaround, falling back on default, not the default, but on Databricks Spark streaming. Um, some low latency requirements. I think over our journey, we have for some scenarios kind of hard requirements for latency, and I think interesting enough, with the recent announcements that Tecton made, I think Tecton as well moved quite a lot, quite far in this kind of low latency space, and I think kind of what we see as the most important lesson is that this partnership is a key, right? Is we do not think in terms of kind of consumer provider, like vendor, and somebody is like buying licenses, right? I strongly believe that it doesn't work like in SaaS business, in consumption business, in cloud business. You have to really kind of pick your partners like wisely, and that's the most important. Like if some features are not missing, and we had many of them, like, we almost like co-created some of those with Tecton, and that was really, I think, the key recipe for success. If you kind of pick your partners wisely and like ready to contribute. I remember, we had engineers like debugging, some materialization jobs, like together with, Tecton support engineers, right? So you have to invest to make it work. I don't want to sound like super naive and simplistic. Well, everything worked from day one. It's kind of, quite complicated domain. It actually way more complicated as it might look like, because of all this peculiarity and details. What capabilities do you need to do your features, like real production features? And yeah, partnership was a key, and I think for us, that sort of I guess raised our confidence very, very high. Like no matter what we faced, actually we literally overcome, I think, all of our main like obstacles. Only thing is that at some point we had to like sort of align our expectation and the roadmap and backlog of Tecton, and kind of wait for some time when those things like became available, and not build our workaround. So was a really great journey, and I think we are very happy in that sense. It was actually a right choice. We are quite, I think it became like one of our highlights, I think, in our all engineering organization, and I would say we really made the feature store work for us. And yeah, next big thing is how to capitalize on what we have in terms of the features and the pipelines in this new world that everybody, I'm sure, thinking about and talking about, world of Gen AI and LLMs. But that's what we I think on top of our mind, in terms of kind of excited future, but like less of clarity, a lot of immaturity, a lot of challenges, and kind of in this classic traditional machine learning space, I think we have pretty mature, solid platform which we can rely as a business. Actually, our maturity score has moved as well, quite a lot. I think we didn't achieve exceptional still, but we are somewhere between like 4 and 5 in that grade. Depends on the dimension that we assess in our platform. Yeah. So that's our story. Thanks a lot. Thanks for listening.
Cool. That I learned a lot. Thank you for a lot of the kind words about Tecton. Actually, it's really good to learn that level of detail about your journey. And yeah, I think this last point is quite interesting, and not to be kind of undervalued or underappreciated. That this domain, I think, Andrei, this is what you were saying. Like, this domain is actually like a pretty deep domain when you're doing something in production here, and you like, I can speak from the Tecton perspective. We talk to a lot of teams where they have, it's a smallish company, and they've got a subset of people that they think that they assign to kind of like solving these set of problems. And then the kind of canonical thing that we joke about internally is, as then once those teams starts digging in, they realize, oh, this problem is like deeper and broader and more complicated than we expected. And so we find that it's really important for us to be really good partners for our customers. It's not just like, hey, here's our software, go use it. Because as you said, there's new things that are going to come up. You guys are building a new product or whatever it is, and we want to be there to help you guys along the way. Very cool. Okay, so we got, let me see, a couple of minutes. I think it just said so, like a couple of minutes. Love to go through some of these questions here. It looks like you answered this, but first question that I see, the most recent question, it moved. Technology induced stress. Okay, sorry, it just flipped. Okay, the question I wanted to ask is, here it is. Did Flo consider implementing an in-house feature store? Sorry, a bunch of questions came in at the same time, and like made me lose track of it. Did Flo consider implementing an in-house feature store? Why did you decide on going for a third-party solution?
I think we didn't consider implementing our feature store for two reasons. One is we strongly believe is that we, and actually we are still a startup. We have to focus on our core value and core advantages, and building technology. We are not in that business as a company. So it's kind of in the question of like build or buy, I would say always consider kind of a buy scenario. Yeah, so no, that was not an option. It's a short answer.
Okay, cool. And maybe like a follow-up question there. I think sometimes it can feel to someone like, hey, this is actually just a straightforward thing that I can build pretty quickly, because they perceive, this problem domain from a specific angle where they really appreciate just a subset of the problem. What do you have in mind there? Like, were you at one point thinking, wow, this is going to just be a really straightforward, simple thing, or from the beginning did you realize, hey, this is a larger problem?
No, it's actually a larger problem. I myself, I spent some time in at least it was called back then, data programmability space, like even before Spark, right? So we kind of was a university where we kind of built almost like somewhat similar, right? I think many people did the same. So, and it's kind of hard to say, but there are so many details, right? It's just a hard problem, right? Because of how hardware works, how network work, how our modern hardware architectures, kind of programming models, programming languages. So kind of stacking up all of that kind of together, and still in a somewhat attractive, easy like developer experience. I mean, this is a hard problem. And what we actually did, I think, to illustrate that point, like was I think around 3 years ago, probably a little bit less. We run at Flo. We have pretty like disciplined way. How do we select technologies, tools, basically all kind of things. We use approach approach, which is called ADR. So we write basically these ADR documents where we very explicitly like formulate, what is our problem, what are we trying to address with that solution or product, and then we basically pick evaluation criteria. How do we want to compare? And then we try to compare different options. And I think I will not probably give names, but actually all of those kind of feature stores that were on the market at that point, they have failed even our initial use cases, like something that we knew we need to check, in terms of, I think, data types that we need to support, some latency requirements, kind of the alternatives, they just kind of fail straight away. And because there was a minimum, I don't know, 5 seconds or some crazy stuff, and sort of basically we more or less left, I think, with Tekton or Feast, to be honest. So that was more or less for us, I think, the choice. And we still didn't want to deploy and run our, basically open source solution, because it's still not non-zero effort to keep it running, maintaining, monitoring, etc. So basically we picked kind of this enterprise SaaS option from Tekton, which sort of, as I said, allowed us to get this powerful engine, but without managing it ourselves, right? And we do the same like with Databricks, right? We moved from self-managed Spark. We shut down our hosted notebooks, and so there are many scenarios like this, I think, over time where we started growing. Our strategy was just to shut down, custom run, stuff and move into mature partners. So it became kind of, I think, quite a successful part of our engineering strategy.
Awesome. And you guys have done also a great job of answering these questions live or in text as well. One of the things that one of these questions, you guys already answered it, but I'll throw it your way for everybody to hear. It kind of touches on a potential misconception about this technology. So Kevin asks, I would expect that storing training data in a feature store via REST API would be slower than pulling data directly from local binary storage. That will slow down training. Am I missing something? So what is this person missing? What should they know?
I've answered that question in text. So we use the offline store to train the models, and we in some cases we calculate features from source using Tekton, and the offline store is actually Delta Parquet files stored in S3, which means that if you can copy them, you can access them in different ways, and training is not slowed down in any way.
Awesome. Yeah, I think what Tekton provides is, so I'll just give kind of the Tekton answer there. Developer tools to develop, to kind of engineer features, to build these pipelines, and the infrastructure to run them in, and hopefully the most efficient way possible across both environments, the development land, the offline world, and online world. Online being hyper optimized, reliable, very fast production serving, and then the offline world being using all of the relevant object storage. So, Demetris mentioned S3, Parquet files, Delta files, Delta format to power training. And so it's not about adding another layer in there. Those files are just directly there that you can access from anything.
Right.
So the point is that you should never really be losing any performance or cost efficiency by using a platform like this. It's really just bringing those optimizations and best practices to the flows across training and production serving.
And I think the important is that you get consistency. What Tekton gives you is you get consistency between production, serving and basically offline training data. That's the most important, because like, it's one of the things that kind of feature stores help, right? Because if you start building like on your own, it's not only about exposing some data from S3, that's kind of simple, but then ensuring this consistency, right? So that your model is being served, like the model is trained on the same data, is being served with the same features that you expect it to be served, right? So if you kind of start thinking about this is what known as a kind of consistency problem, and Tecton sort of handles that for you.
Awesome. Guys, well, thank you so much for sharing all your wisdom today and sharing this journey. I think everybody learned a lot. I learned a lot. I thought it was really cool, and I love what you guys are doing. We just so everybody knows, there is a little bit of like Tecton wrote up a little bit of a case study with the Flow people, and so it's on the Tecton website if you're interested in learning more. I'm sure you could reach out to Andrei and Demetris. You can also of course, reach out to Tecton if you're interested in learning more about Tecton, and we'll have more of these. So thank you so much, Flo folks. We really appreciate it, and we will see you soon.
Thank you for having us.
Thank you. Thanks for having us. Thank you.
Take care, guys, and thank you for the great questions. Cheers.
Cheers.
Cool. Andrei, thank you, man. I don't know if Demetris is still here. Appreciate it. I'm gonna have my team reach out to you about the embeddings thing. I already messaged them, so it's gonna happen hopefully today.
Cool.
Take care, man.
You don't
See ya.
Thank you.